Let's do some problem solving with whatever we have learned in the last few sessions. Now, what would be the limit as x approaches 0 of e to the power of 1 by x by e to the power of 1 by x plus 1? Don't use any techniques. We just use the left hand limit, right hand limit, and see whether they both exist and whether they are both equal. Then we say the limit exists. Okay, so let's look at LHL. Now the simplest way of figuring it out is wherever you have x for left hand limit, replace it with the x value that we are interested in minus h. In case of right hand limit, value of x plus h. So have a look at this. So limit x approaches 0 from the left hand side minus of e to the power of 1 by x by e to the power of 1 by x plus 1. Now this can be written as limit as h approaches 0 of e to the power of 1 by 0, that is the value of x that we are interested in, minus h. See, remember, we can't really write 0 itself. Okay. Similarly, e to the power of 1 by 0 minus h plus 1. So we are going very near to 0 from the left hand side. Limit as h approaches 0 of 1 by minus h, or we can say minus 1 by h, e to the power of minus 1 by h plus 1. Now limit, let's actually take the limit now. Now 1 by h would go to infinity. That means minus 1 by h would go to e to the power of minus infinity by e to the power of minus infinity plus 1, which is equal to, this is, remember, e to the power of minus infinity is 1 by e to the power of infinity. 2.7 to the power of infinity will give you a very large number. 1 by of that will give you what? 0. Right? So think of it like this. E to the power of minus infinity is nothing but 1 by e to the power of infinity, which is nothing but 2.7 dot 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 to the power of infinity. The denominator will keep becoming larger and larger and larger. So 1 by denominator, a large denominator, would tend to 0. So 0 divided by, it is not 0, it is 1. Why? Because this becomes 0, but we still have that 1. So it becomes 0 divided by 1, which is equal to 0. So the left hand limit is 0. Now right hand limit. So limit as x approaches 0 of e to the power of 1 by x by e to the power of 1 by x plus 1 can be written as limit as h approaches 0 of e to the power of 1 by 0 plus h. This is from the positive side. No, not this one. This is from the positive side, divided by e to the power of 1 by 0 plus h. Put brackets, otherwise division takes priority. Plus 1. Okay, so this is equal to, let's do a little bit more simplification. So this becomes e to the power of 1 by h by e to the power of 1 by h plus 1. Let's do some cancellations. So e to the power of 1 by h by, let's take out e to the power of h common. So 1 plus 1 by e to the power of 1 by h. These two get cancelled. So we are left with limit as h approaches 0 of 1 by 1 plus 1 by e to the power of 1 by h. Now let's take the limit. Now what happens? 1 by 1 plus This becomes what? E to the power of 1 by h, e to the power of 1 by h. So h goes to 0. So 1 by 0 is infinity. E to the power of infinity is infinity. But we are talking of 1 by infinity. This whole thing is 1 by 1 by. So 1 by infinity will give you 0. So plus 0. So which is 1. Now both left hand limit and right hand limit exists. One is 0, one is 1. But left hand limit is not equal to right hand limit. So therefore limits at x equal to 0 does not exist. Now let's look at the next problem. Limit as x approaches 0 of x sine 1 by x. And parallelly let's try out something else. Let's parallelly do third. Limit as x approaches 0 of x cos 1 by x. Now again LHL would be limit as x approaches 0 from the minus side of x sine 1 by x. Limit as h approaches 0 of 0 minus h sine 1 by 0 minus h. Limit as h approaches 0, we get minus h sine minus 1 by h. Limit as h approaches 0 of sine minus theta is equal to minus sine theta. So which means minus into minus plus. So we end up with h sine 1 by h. Now this is equal to 0 times some value, a value between minus 1 and 1. Yes. So 0 multiplied by anything is 0. So the left hand limit is 0. Let's do for this also. LHL limit as x approaches 0 from the left hand side of x cos 1 by x. This is equal to limit as h approaches 0 of 0 minus h cos 1 by 0 minus h. Now this again as h approaches 0 of minus h cos minus 1 by h. Now cos minus theta is equal to cos theta. Yes. So limit as h approaches 0, this remains negative, minus h cos 1 by h. And when we take the limit, we get 0 minus 0 times a value between minus 1 and 1, which is equal to 0. Okay. Now let's look at RHL, right hand limit. Now let's say limit as x approaches 0 from the positive side of x sine 1 by x. Limit as h approaches 0, 0 plus h times sine 1 by 0 plus h is equal to limit as h approaches 0 of h sine 1 by h, which is equal to 0 times a value between minus 1 and 1, which is equal to 0. And if you notice, when you do this, you will see that this is also the same from the positive side of x1 cos 1 by x. So limit as h approaches 0 of x plus h, 0 plus h cos 1 by 0 plus h, which is equal to limit as h approaches 0 of h cos 1 by h, which is equal to 0 times a value between minus 1 and 1, which is equal to 0. Now in case of x sin 1 by x, LHL and RHL both exist, and LHL is equal to RHL, which is equal to 0. So therefore the limit exists. Similarly here, LHL and RHL exists, and LHL is equal to RHL equal to 0. So the limit exists in both the cases, and it is 0. Now let's look at the fourth one. Limit as x approaches 0 of magnitude of x by x. We need to evaluate what the limit is. So let's look at LHL. Limit as x approaches 0 from the negative side of magnitude of x by x is equal to limit as, now instead of x, let's say h tends to 0 of, it is 0, we are approaching 0, so 0 minus h divided by 0 minus h, which is equal to as limit h as h approaches 0 of minus h by minus h, magnitude of minus h by minus h, as limit as h approaches 0 of, this becomes plus h, this is minus h, so these two get cancelled and we are left with minus 1. So when h becomes 0, it is minus 1. Okay, you have to cancel these first and then take the limit. Otherwise, you will end up with a 0 in the denominator. Now, let's look at the RHL. So, limit as x approaches 0 from the positive side of x, magnitude of x by x. Now, this would be limit as h approaches 0 of magnitude of 0 plus h by 0 plus h, which is equal to limit as h approaches 0 of h by h 1. So which means 1. Now LHL and RHL both exist, but LHL is equal to minus 1, RHL is equal to 1. So they are not equal. So therefore no limit exists. Let's look at the fifth one. Show that limit as x approaches 2 of f of x is equal to 7 if f of x is equal to, and depending on the condition, 3 minus x square if x is less than minus 2, 0 if x is equal to minus 2, and 11 minus x square x is greater than minus 2. Now we have to find the limit at x equal to, as x approaches 2. Remember, you can't just do substitution. Don't just substitute it and solve it. We have to figure out both left hand limit and the right hand limit. So as x approaches 2, what is happening? It is greater than minus 2. It doesn't apply to any. So which implies, now that is the case whether it is approaching from the left or whether it is approaching from the right. So in either case, we are going to be looking at f of x is equal to 11 minus x square. So LHL, limit as x approaches 2 from the left hand side of 11 minus x square. Okay, so this we can write it as limit as x approaches to instead of saying x approaches 2 from the left hand side, we say h approaches 0, and we say 11 minus 2 minus h square. So limit as h approaches 0 of 11 minus 4 minus 4h plus h square, or limit as h approaches 0 of 7 minus 4h plus 4h minus h square, which is equal to 7. That is left hand limit. RHL would be again limit as x approaches 2 from the positive side of 11 minus x square, or we can say as h approaches 0 of 11 minus 2 plus h square. So limit as h approaches 0 from 11 minus 4 minus 4h minus h square. This is nothing but 7. 11 minus 4 is 7. So this would be when we take the limit to 7. So therefore LHL equal to RHL is equal to 7. Okay, finally limit as x approaches 1 of x square minus 1 by x minus 1. Left hand limit, limit as x approaches 1 of x square minus 1 by x minus 1 can be written as limit as h approaches 0 of 1 minus h square minus 1 by 1 minus h minus 1. Okay, so this becomes limit as h approaches 0 of 1 minus 2h plus h square minus 1 by 1 minus h minus 1. So this and this gets cancelled, this and this gets cancelled. Limit as h approaches 0 of h is common, so let's take minus h out. So minus h 2 minus h by minus h. This and this gets cancelled, which is equal to, now when we take the limit, what do we get? When I take h, we get 2 minus 0, which is 2. Now let's look at RHL. So limit as, here did I mention from the negative side? See, usually many times we tend to forget that. That is very important. So as x approaches 1 from the positive side, is from the right hand side of x square minus 1 by x minus 1. See, these things that we miss out now, over a period of time when you start practicing, you will realize that this is the type of mistakes that we do. So once you have completed the problem, just review your solution and see whether you have made those mistakes. So we can write this as limit as h approaches 0 of 1 plus h square minus 1 by 1 plus h minus 1. Okay, so limit as h approaches 0 of 1 plus 2h plus h square minus 1 by 1 plus h minus 1. So this gets cancelled, this gets cancelled. Limit as h approaches 0 of, again h is common, so 2 plus h by h. These two get cancelled. And now when we take the limit, we get 2 plus 0, which is equal to 2. Left hand limit and right hand limit exists and LHL is equal to RHL equal to 2. Just there are some techniques that we have used previously by which we can make it, we can evaluate whether what we have done is correct or not. Here we were supposed to follow this method, that's why we followed. What we can do is we can factorize it. So a square minus b square is what? X plus 1 x minus 1 by x minus 1. So these two get cancelled. Now we use direct substitution. So 1 plus 1 is 2, which is what we have got. So you solve the problem by the specified method and then you evaluate with some different method which may be faster. Okay, I think that's enough for today. Bye for now.